Question number 4, we have a cell of EMF 1.5 volt. 1.5 volt and then an internal resistance of 1 ohm. Maintains a constant current of 0.5 ampere in an external circuit when an electric charge of 2 coulomb flows in the external circuit. Calculate the thermal energy dissipated from the cell. So that is basically the heat dissipated through the external circuit. So the resistance that you will be using is basically the external circuit, the 1 ohm punya resistor lah. So the equation that you will be using is I square RT. Do we have the time? No, we do not have the time, so that is what we are gonna find first. Okay, let me just think. Okay, so basically from this one here, we know that since we have the value of Q, we actually know that Q is equal to IT. So we can actually substitute this into this equation here by doing this. IT, IR, okay? So, from here, this is going to be equal to Q, IR, where Q is equal to 2, I is equal to 0.5, and the internal resistance is equal to 1, okay? So, the energy dissipated from the cell is basically equal to 1 joule, okay? So that is the heat dissipated from the cell. So that's why we are using the internal resistance lah. Okay, the energy dissipated from the external circuit. So untuk the external circuit, it's not gonna be the internal resistor that we will be using. So instead of using Wi square RT, resistor as in R, since we do not have the value of resistor in the external circuit, we are gonna use the equation W equal to VIT. So what we are gonna find is the value of terminal voltage, okay? So we need to find the terminal voltage first so that we can calculate the heat dissipated through the external circuit, not in the cell, okay? So sekarang kita ada cell, kita ada external circuit juga. So the heat dissipated from this external circuit is not the same as the heat dissipated from the cell lah, okay? So apa yang kita perlu buat dulu, kita perlu cari the value of V, okay? As well as the time lah. So how do we find the time? Since we have the value of Q, we can actually calculate the time like this. So it's gonna be equal to 2 over 1.5, so that is just equal to 4 seconds. Alright, so after that, we have to find the value of V, which is the terminal voltage for this equation here. So how do we do that? We know that the equation of terminal voltage is this one here. So we can just substitute lah apa the value. So EMF is equal to 1.5 minus 0.5, internal resistance is 1, okay? So kira lah kamu kira, lepas tu kamu akan dapat the terminal voltage which will be equal to 1 volt. Okay, so dapatlah jawapan dia. So kamu just perlu substitute. The heat dissipated through the external circuit is 1 times 0.5 times 4. So it's gonna be equal to 2 joule. Alright? Okay, so that is question B. Now we have to do question C, where we are asked to calculate the total energy supplied by the cell. So the total energy supplied by the cell is basically the heat dissipated. Okay, so I actually should label them, right? Because this is for cell. And then this one is basically the external circuit. So the total energy supplied is actually just the addition of this heat dissipated from the cell and the external circuit. So it is basically equal to 1 plus 2, which is equal to 3 joules. Okay, or you can also use another method that you can do is by using the EMF, which is the total energy supplied by the cell times with the current and the time that we've calculated earlier. So this is 0.5, this is 4 seconds, so you will get the same answer, which is 3 joules. Okay, all right, so this is the solution for question number 4.